The innovation, the next wave of big biology is going to come from somewhere else. And one of the areas that we believe is going to come from is the analysis of genome structure. And that requires a completely new paradigm. And so we've been building our company to drive that shift. There are a number of cytogenetic tools that are used today, and we can really come in and provide a very efficient workflow. But when we also think about the sequencing that's going on in the space, a lot of it, 60, 70% of sequencing, is for some research application to ask some basic question about biology and medicine. And so if you're asking questions, you're going to want to have all of the tools available to you in your repertoire. And so we believe optical genome mapping is one such tool. Long-read sequencing can only see, about 10,000 base pairs. It says 1,000 base pairs, but it's really about 10,000 base pairs, whereas we're looking over hundreds of thousands of base pairs. Now, I've been talking to you a lot about structural variations, and hopefully some of you are wondering, what are these structural variations and why haven't I heard about them before? And I think the answer to that question is in this slide. On the one hand, the traditional methods that are used to detect them are pretty antiquated. They've been around for a long time, and they're very slow and cumbersome to implement on a really big scale. And so this molecular revolution that we've seen driven by sequencing just hasn't caught up with this space because the methods for genome structure analysis are not sequencing based. On the other hand, you haven't heard about them from the sequencing companies because sequencers don't really reliably detect structural variations. And so we have an opportunity that's perhaps missed by a lot of the companies that are going after genome variation today, because the real opportunity is in consolidating the multiple methods that exist within traditional cytogenetics, molecular and anatomic pathology into a single workflow based on optical genome mapping. And so that's really what we're focused on. If you look at the historical throughput increases that we've been able to achieve, about 14-fold increase since the launch of the Saphyr system. We're up to about 5,000 samples per year now, but we're forecasting a new system that will take that up by another factor of 14. First, through an intermediate step that'll be available to the market in the first quarter of 2023. And then a second innovation that will gang several of those systems together to produce finally 70,000 samples per year. And so what we will have in the market is our existing system at 5,000 samples per year or fewer, and then a high throughput system that serves really high volume central labs doing all sorts of testing. And so our roadmap and the catalyst that you're going to see coming out is going to be based around these clinical studies that are ongoing and all the data that they're throwing off,